some basic problem of Lagrangian. Okay. So today we will just try to solve some problem, and let's try to see how all the information, whatever we have learned earlier, is important to solve the Lagrangian problem. So obviously, what we have Lagrangian L, and that L is nothing but, right now I can just say this is T minus V. And if this is my Lagrangian, and obviously this is function of generalized coordinate, generalized velocity, obviously function of time. And the same time, we can have equation of motion. So d upon dt del L upon del qi dot minus del L upon del qi is equal to 0. And we can also have a concept of generalized momentum. So generalized momentum is nothing but del L upon del qi dot is nothing but pi. This is our generalized momentum. And we have also concept of cyclic coordinate. So del L upon del qk, that is some particular coordinate. It is not necessary that in one particular problem you can have cyclic coordinate. It is not necessary. Depends on situation, depends on problem. So we have cyclic coordinate. We can have cyclic coordinate, and that value is equal to 0. And if qk is cyclic coordinate, which implies pk is conserved or constant of motion. So the summary of last 3 and 4 classes, just these things. But what is most important thing? The most important thing is that number of generalized coordinate must be equal to number of DOF. So number of generalized coordinate must be equal to number of degree of freedom. If you have this kind of situation, then obviously you can work in a very nice way. So the whole challenge is that we have to make sure that number of generalized coordinate is equal to number of degree of freedom. Right now, I think everyone is comfortable up to this. So let's try to go for some basic problem. So the problem is, so there is a particle, and this particle has mass m, and this is moving in a surface of ball, and this is my ball. Okay, in a surface of ball, and the equation of ball is given in a Cartesian coordinate. It's something half b x square plus y square. This is your equation given. So this is something kind like a paraboloid. So if you have parabola and you can rotate about z axis, so you can just assume this is x, this is y, and this is my z axis. So particle is somewhere at this particular point, and yes, gravity is in the direction of negative z direction. This is your particle at this particular point. So what we have to do, we have to write the Lagrangian. So we have to write the Lagrangian in cylindrical coordinate. In cylindrical coordinate. And once we will write the Lagrangian, then obviously we have to identify cyclic coordinate. So we have to identify cyclic coordinate if there is any. Identify cyclic coordinate. And once we identify cyclic coordinate, we can always talk about the conservation of momentum. Let's see whether linear momentum is conserved or angular momentum is conserved. And then we have to go for equation of motion. Okay, let's try to go for this. Okay, so how you will proceed this type of problem? Don't worry, always try to proceed from the Cartesian coordinate. Just go from Cartesian coordinate. There is not any problem. So you can choose origin, and I can choose this point as origin. This is the most suitable point for the origin. And if I can choose this as a origin, and I will just keep this particle as a free. I will just keep this particle free. So this is nothing but x, y, and z. So obviously the system is what? Two-dimensional system or three-dimensional system? Obviously the system is three-dimensional. Okay, it is rotating and it can just go in a vertical direction. So first we have to write the kinetic energy and potential energy in a Cartesian coordinate system. That is the simplest thing we can do. And after then we will start to doing the analysis. So let's try to write the kinetic energy. What is kinetic energy? The kinetic energy is all about in a Cartesian coordinate is half m x dot square y dot square plus z dot square. This is my kinetic energy. What is my potential energy? This is at the height z. I can assume this is my zero potential. So what is my potential energy? That is nothing but what? mgz. So this is my potential energy. Now we can write the Lagrangian for this particular thing. So let's try to go for writing the Lagrangian. So I can write Lagrangian as half m x dot square plus y dot square plus z dot square minus mgz. This is nothing but kinetic energy minus potential energy. Now the second thing is that we have to convert whole thing in a cylindrical coordinate. Yes, we have to convert whole thing in a cylindrical coordinate. So how you are going to convert the cylindrical coordinate? You will just put x is equal to r. What will be cylindrical coordinate? X is equal to r cos theta, y is equal to r sin theta, and z is equal to z. So we can easily convert them in a cylindrical coordinate. So when we will go for cylindrical coordinate, then we can have half m r dot square plus r square theta dot square plus z dot square minus mgz. This is my Lagrangian in cylindrical coordinate. Now, from here we have to analyze what will be the degree of freedom of this particular system. Can anybody tell me what is degree of freedom? क्या बता सकते हो क्या हमारे डिग्री ऑफ फ्रीडम है? Just tell me what is my degree of freedom? Anyone? Neha, can you please tell me what is degree of freedom? No. Rupali?
Sir, 3.
3 डिग्री ऑफ फ्रीडम है पक्का? कैसे निकाला आपने डिग्री ऑफ फ्रीडम? कैसे निकाला जरा बताइए? How many particle is there? You have 3 into 1 number of particle is there. And what is your equation of constraint?
2 degree of freedom.
Yes, there is 2 degree of freedom. Very good. But just tell me what is equation of constraint?
Equation of constraint.
बताइए. What is equation of constraint? What is equation of constraint? Equation of constraint किसे कहते हैं?
The restricted motion.
The relationship between the dynamical variable. So what is equation of constraint here? This is equation of constraint, isn't it? Is that your z is independent to x and y? No, z is not independent to x and y. So this is the equation of constraint. In this whole Lagrangian, where is the story that your particle is moving on a ball? Or where is the story that your particle is moving in this particular shape? हमने कहीं use तो नहीं किया है. And what is this? This is your equation of constraint. Z is equal to half b x square plus y square. So how many equation of constraint is there?
1.
One equation of constraint. So you have degree of freedom. Your DOF is equal to what? 2. This is your 2 degree of freedom. Now, here you have 2 degree of freedom, but how many generalized coordinate you are using here? कितना use कर रहे हो?
Sir, 3.
3. So is that this is a correct Lagrangian for this system?
No, sir.
No, this is not correct Lagrangian. Your number of generalized coordinate or number of degree of freedom must be equal to number of generalized coordinate. So what we have to do? We have to include this thing in my equation. So now ये जो दिया हुआ है z is equal to bx square plus y square, ये किस coordinate form में दिया हुआ है?
So Cartesian.
Cartesian coordinate form. But आपको लिखना किस form में है? Cylindrical form में लिखना है. So what you have to do? You have to convert this Cartesian to cylindrical form. So just you can use x is equal to r cos theta, y is equal to r sin theta, then z is equal to something half b r square. Yes, z is equal to half b r square. This is your equation of constraint in a cylindrical coordinate. So now you can calculate it z. Can I calculate z dot here also? Yes, we can easily calculate z dot. What will be z dot? Z dot is equal to b r dot. This is value of z dot. Now we can put it all this thing here. So we can write half m r dot square theta dot square, and this particular thing is what? B square r dot square minus mg, and what is your z? Z is equal to nothing, b r square by 2. Now you can see how many generalized coordinate you have. कितना generalized coordinate है अभी?
2.
2 generalized coordinate. What are these?
2.
क्या क्या है ये?
Sir, r and theta.
Very good. R and theta is my generalized coordinate. And how many degree of freedom is there?
So 2 degrees of
2 degree of freedom. So 2 degree of freedom is equal to number of generalized coordinate, and that is also 2. So yes, this Lagrangian is correct in nature. So what I can do, I can write this as half m. I can जरा आप म्यूट कर लो, किसी का अनम्यूट है ना? R dot square 1 plus b square r square plus half m r square theta dot square minus m g b r square by 2. So this is my Lagrangian of a system. And what is my generalized coordinate? There are 2 generalized coordinate. The first generalized coordinate is all about r, and the second generalized coordinate is all about theta. Clear है ये? Yes, यहाँ तक कुछ पूछना है तो आप पूछ सकते हो. Now, just okay. Now just tell me, what is your cyclic coordinate? क्या cyclic coordinate?
Theta.
Very good. Theta is my cyclic coordinate. How do you know? You can easily calculate del L upon del theta. So this Lagrangian is not explicit function of theta. So del L upon del theta is equal to 0. That means theta is cyclic coordinate. So if this theta is cyclic coordinate, which quantity is conserved?
p theta.
P theta. Very good. Very good. Excellent. So P theta is conserved. What is P theta? Del L upon del theta dot. This is definition of P theta, है ना? And how you will get it? You will get that nothing but mr square theta dot, and which is conserved. What is mr square theta dot?
Angular momentum.
Angular momentum. किस डायरेक्शन का angular momentum है? R, Z cap direction का angular momentum है ना? Because it is moving in XY plane, so this is in Z cap direction का angular momentum है. So this is your conserve. So अगर आपसे कोई पूछे इसमें कि भाई कौन सी quantity conserve है, क्या linear momentum conserve है? No, linear momentum is not conserve. What is conserve is the angular momentum, and that direction of angular momentum is along z cap direction. Now we have to go for equation of motion. अब हमें क्या करना पड़ेगा? We have to write equation of motion, है ना? So let's try to write the equation of motion. किस coordinate system में equation of motion लिखेंगे? Just tell me. किस coordinate system में equation of motion लिखोगे आप? थीटा में लिखे या आर में लिखे? आर में लिखो, बिकॉज थीटा इज साइक्लिक कोऑर्डिनेट, तो फिर हमें कोई जरूरत नहीं है लिखने की. सो लेट्स ट्राई टू गो फॉर इक्वेशन ऑफ मोशन फॉर आर. व्हाट इज इक्वेशन ऑफ मोशन? डी अपॉन डी टी डेल एल अपॉन डेल आर डॉट माइनस डेल एल अपॉन डेल आर मस्ट बी इक्वल टू 0. सो आई एम जस्ट गिविंग यू होमवर्क. जरा आप लिखो, मुझे लगता है कहीं ना कहीं कुछ गलती करोगे. So just try to write the equation of motion and post me. Post करोगे ग्रुप में? आप करते तो है नहीं कुछ, but anyway, just try to do this thing. So इसको आप करो, मैं कल आपको इसका फाइनल आंसर दूंगा. Okay? Everyone is comfortable up to this? कुछ पूछना है तो पूछ सकते हो. Then we will go for next problem. This is your homework. Just try to figure it out. What will be your equation of motion? चलो, so let's go for next problem. Next problem करें हम लोग. चलो, so let's go for particle in a inner surface of cone. इसकी बात करते हैं, ठीक है? So this is my cone. ये हमारा cone है, and we have to write something like this. This is x, y, and z. And let's say this angle is alpha. ये angle क्या है? Alpha है. What I have to do? I have to write the Lagrangian of a system in a spherical polar coordinate system. अभी हम किस कोऑर्डिनेट सिस्टम में बात कर रहे हैं? अभी इससे पहले किस में किया था प्रॉब्लम को सॉल्व? सिलिंड्रिकल कोऑर्डिनेट में. हियर वी आर जस्ट गोइंग टू सॉल्व इट इन spherical polar coordinate. So let's say this is mass of a particle and particle is here. And obviously I can take this as a origin. This is the simplest to write origin. Okay. So we have to write the Lagrangian of a system. So we have to write Lagrangian in which coordinate system? In a spherical polar coordinate system. In a spherical polar. Then we have to find cyclic coordinate. Okay. And then we have to write the equation of motion. By the way, why we are finding the cyclic coordinate? What is purpose behind finding the cyclic coordinate? क्या purpose है?
From which we can calculate that which quantity is conserved.
Very good. From where you can calculate which quantity is conserved. Mainly angular momentum or linear momentum. Very good. क्या नाम है आपका?
Sir, किशोर कलिता.
Okay, very good. Good. Great. चलो, so इसको लिखना शुरू करें. बताओ फर्स्ट स्टेप क्या होगा किशोर? आप बताओ. पहला स्टेप क्या करें?
सर कार्टेशियन में लिखना पड़ेगा.
कार्टेशियन में इसको फ्री मानकर लिख लें, है ना? तो चलो कार्टेशियन में लिख लेते हैं. सो लैग्रेंजियन क्या होगा? दैट इज t minus v. So what will be this? Half m x dot square plus y dot square plus z dot square minus mg z. यही तो होगा पोटेंशियल. दिस इज योर g, दिस इज योर हाइट z. सो दिस इज योर कार्टेशियन कोऑर्डिनेट. नेक्स्ट हमें क्या करना पड़ेगा, इसे किस कोऑर्डिनेट सिस्टम में लेके जाना पड़ेगा?
सर स्फेरिकल में.
स्फेरिकल में, क्योंकि प्रॉब्लम दिया हुआ है स्फेरिकल में, तो स्फेरिकल में चेंज कर दे सारे चीज को. सो इफ यू आर गोइंग टू चेंज इट, देन व्हाट विल बी हैपन? x की वैल्यू क्या पुट करोगे? r sin थीटा cos phi. व्हाट इज y? r sin थीटा sin phi. What is z? r cos theta. So we can put it, we can find x dot, y dot, z dot. ये सारा हम लोगों ने काम कर रखा है और इसे हम स्फेरिकल पोलर में लिख देंगे. That is half m r dot square r square theta dot square plus r square sin square theta phi dot square minus mgr cos theta. यहां तक तो क्लियर है? ठीक है ना?
Yes,
आर
sir.
पीपल कंफर्टेबल दैट हाउ वी आर गेटिंग फ्रॉम हियर टू हियर? ये हम लोगों ने पहले प्रैक्टिस कर रखा है. ठीक है, ओके. चलो, इज दैट दिस लैग्रेंजियन इज करेक्ट? चलो बताओ, क्या ये लैग्रेंजियन करेक्ट है?
नो सर.
नो, व्हाई नॉट?
सर क्योंकि थीटा इज इक्वल टू अल्फा, मतलब ये कांस्टेंट क्वांटिटी है, जिसको कांस्टेंट कह सकते हैं.
वेरी गुड. तो बेसिकली हमने यहां पर ये जो कोन की सिमेट्री है वो कहीं भी यूज नहीं की है ना? आर यू गेटिंग माई पॉइंट और नॉट? बेसिकली आप अगर और भी ज्यादा ऑथेंटिकली कह सकते हो, सो ऑथेंटिकली क्या कहोगे कि नंबर ऑफ डिग्री ऑफ फ्रीडम कितनी है हमारी इस प्रॉब्लम में? व्हाट इज योर नंबर ऑफ डिग्री ऑफ फ्रीडम?
सर 2.
2. Very good. We have already calculated in last classes. So this is my, so we have to calculate number of degree of freedom. 3 into number of particle, you have degree of freedom 3 into n minus k. 3 into number of particle is 1 minus k. कितने equation of constraint है? 1. Very good. What is that in a spherical polar coordinate? Theta is equal to alpha. Yes. याद है क्लास में हम लोगों ने शुरू में किया था डिग्री ऑफ फ्रीडम के समय? इफ यू आर गोइंग, व्हाट इज थीटा? थीटा इज नथिंग बट द एंगल मेकिंग विद द जेड एक्सिस. सो थीटा इज इक्वल टू अल्फा इज द योर इक्वेशन ऑफ कंस्ट्रेंट. सो इफ थीटा इज इक्वल टू अल्फा, देन व्हाट विल बी योर थीटा डॉट? 0. सो व्हाट वी हैव टू डू, वी हैव टू यूज द इक्वेशन ऑफ कंस्ट्रेंट. यहां पर हम इक्वेशन ऑफ कंस्ट्रेंट को लेकर जाएंगे. देन व्हाट विल हैपन? half m r dot square and theta dot is 0, so this term will vanish, and you have r square sin square theta phi dot square minus mgr cos alpha. Everyone is comfortable right now?
Yes, sir.
Okay. Now, how many degree of freedom? There is 3 into 1 minus 1. That is 2 degree of freedom. We have 2 degree of freedom. And how many generalized coordinate we are using? We are using 2 generalized coordinate. The first is r and second is phi. Theta is not my generalized coordinate. Theta is equal to alpha is equation of constraint. Alpha is some parameter. Yes, alpha is some parameter which is constant. So you can easily find what will be your Lagrangian of a system. Chalo. Anubhav, can you tell me what will be cyclic coordinate? Anubhav?
Sir, del L over, sorry, phi.
Phi is your cyclic
नहीं
coordinate.
नहीं.
Very
Yes,
good,
sir.
very good. Phi is your cyclic coordinate. डरो मत, आराम से
Yes,
करो, ठीक है?
Yes,
है?
sir.
ओके, हड़बड़ाना नहीं है. ज्यादा से ज्यादा गलत होगा, है ना? और उसको तुरंत ठीक कर लेंगे. So don't worry. Don't feel shy to give the answer, है ना? थोड़ा इंटरेक्टिव बनाओगे तो मजा आएगा. So what is, how you can know? You have just calculated del L upon
Del L over del
phi is equal to 0. है ना? कहीं भी phi नहीं, phi dot है but phi नहीं है. So phi dot is there, phi is not there, so that means it is a cyclic coordinate. So which quantity is conserved? अनुभव आप ही बताइए. Which quantity is
Sir,
conserved?
phi, P phi.
P phi.
Momentum in
Very
direct-
good.
Yes.
Very good, very good. P phi is conserved. So if P phi is conserved, what is this P phi? बताओ.
Del L over del Z.
Z कहाँ है यहाँ पर? Z तो है ही नहीं. What is
Del
your?
L over del.
हाँ बताओ. या
For
del L upon
phi.
del phi dot. Del L
Del phi
upon
dot.
del phi dot, है ना? हमेशा जनरलाइज वेलोसिटी के साथ जब डिफाइन करते हैं, then you are getting this particular cyclic coordinate. Okay? So when you are going to calculate it, then this value is, जरा कैलकुलेट करके बताओ क्या होगा. देखें कौन फटाफट करके फर्स्ट बताता है. What is this value?
Sir, 2r squared sin squared theta phi dot.
सोच लो, मार्क्स कट जाएंगे.
Sir,
M
m r squared, not 2, sir.
हाँ, क्या हो जाएगा? m r square sin square theta phi dot, which is conserved, which is constant. Okay? So can I write phi dot is equal to c upon m r square sin square theta? खुश हो यहां तक? हाँ या ना? Can I write this thing? Now phi
Yes, sir.
dot is inversely proportional to r square. इसका मतलब क्या होगा? By the way, what is r here? यहाँ पर r क्या है? Anyone?
Radius in which XY plane where the particle is moving. R
पिटाई
is equal
लगेगी
to
तेज. पिटाई तेज लगेगी. स्फेरिकल पोलर कोऑर्डिनेट में है. What is r in spherical polar coordinate? What is r in spherical polar coordinate? बताओ.
ओरिजिन से पार्टिकल की डिस्टेंस.
Very good. Origin से particle के distance. This is your r, isn't it? This is your r. है ना? अगर r ये होता तो फिर हमें किस कोऑर्डिनेट सिस्टम में जाना पड़ता?
Cylindrical.
सिलिंड्रिकल. जाके फिर से आज रिवाइज करोगे, ठीक है, जो कोऑर्डिनेट सिस्टम दिया है ना? अब आपका ज्यादा क्लियर होगा. नाउ दिस इज योर r. ठीक है. अब देखो, r की वैल्यू अगर बड़ी होगी, इफ r विल बी बिगर, देन phi dot will be smaller.
Small r.
Very good. If r will be bigger, then phi dot will be smaller. So what will happen? At the higher r, जब पार्टिकल दूर रहेगा ओरिजिन से, तो वो धीरे धीरे घूमेगा या फास्ट घूमेगा?
धीरे धीरे घूमेगा सर.
धीरे धीरे घूमेगा. Very good. That will move very slowly. So this will move very slowly. And as it is going towards origin, what will happen?
It will move fast.
It will move faster, 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 and very faster. What will happen at r is equal to 0? What will happen at r is equal to 0? बताओ. When r is equal to 0, phi dot is equal to infinity? Yes?
Yes,
When
sir.
r is equal to 0, phi dot की वैल्यू क्या हो जाएगी? Infinity? Is that possible? ये possible है? No, it is not possible. How you will get the infinite angular velocity, which is not possible. So what will happen next? Suppose the particle is going down and moving faster and faster and faster. What will happen next? Then particle will again go upward. और फिर वो नीचे आएगा और फिर वो ऊपर जाएगा. Let's see how it is going to happen. यहाँ तक clear है ना?
Yes, sir. Clear.
Okay, चलो. So let's try to go for equation of motion. ठीक है? So this is the value of phi dot. Let's try to go for equation of motion. चलो. So what is my Lagrangian? First I will write Lagrangian. Lagrangian is half m r dot square and then r square sin square theta phi dot square माइनस एम जी सॉरी साइन स्क्वायर अल्फा, थीटा की जगह पर यहाँ अल्फा करेंगे ना, दिस इज प्रॉब्लमेटिक। ओह, मैंने क्या लिखा था फाई डॉट की वैल्यू अभी, जस्ट चेक इट, डेल एल अपॉन डेल फाई डॉट इज इक्वल टू व्हाट, पी फाई है ना, एंड दिस वैल्यू इज इक्वल टू क्या आ जाएगा, एम आर स्क्वायर साइन स्क्वायर अल्फा phi dot, and this value is constant. Okay, so phi dot is equal to c upon m r square sin square alpha. So this is constant. आप थीटा के जगह पर इसे अल्फा चेंज कर लो, है ना, जस्ट मैं ये करना भूल गया था, जस्ट यू कैन चेंज इट। ओके, दिस इज द करेक्ट एक्सप्रेशन। ओके, एक जगह मैंने चेंज किया, दूसरी जगह नहीं चेंज कर पाया था। ओके, यू कैन जस्ट चेंज इट। नाउ दिस इज माय Lagrangian, this is sin square alpha. Now let us go for, and this is what, mgr cos alpha, mgr cos alpha. Okay, let's try to go for equation of motion. What is equation of motion? D upon dt del L upon del R dot minus del L upon del R must be equal to what? 0. ठीक है ये? Okay, so what will happen? We have to just go for equation of motion. Just check it. This value will be mr double dot minus mr sin square alpha phi dot square plus mg cos alpha must be equal to 0. Del L upon del R you will calculate, that is minus. So this minus minus is plus. So this is your equation. So you can write this equation as mr double dot is equal to mr sin square alpha phi dot square minus mg cos alpha. Okay, now let us try to go for analysis of this particular thing. इसको थोड़ा एनालाइज करने की कोशिश करते हैं। ओके, okay, just check it. So you can see this is my situation, है ना, यहां पर पार्टिकल m है। What is this angle? Alpha. Are people there और छोड़ के निकल गए सारे? हैं, जाना तो बता देना, है ना। So that value is mg. Are people happy with this?
Yes, sir.
है ना, and this angle is what? Alpha. ठीक है, now what is this distance? R. This distance is R. Okay, so take the so this is your direction of R cap, this is your direction of R, this is your radial direction R in a spherical polar coordinate. Now you will take component of mg along R, so what you will get? Component of mg along R क्या मिलेगा? Component of mg along R, what you will get? Mg cos alpha. That value is what? Mg cos alpha. The another component is in this direction, so there is not any problem. Mg sin alpha. So now look at here. This is perpendicular to this particular R. So this is along Mg cos alpha. So now look at, this is positive R, this is negative R. So you can have, this is your positive R, this is your negative R. So Mg cos alpha in the negative sign of this particular thing. Yes, this is your downward direction. But by the way, what is this? ये तो एक force है. What is this force? ये force क्या है भाई? Can you identify this force?
Centrifugal.
Yes, that is centrifugal force. What will happen? Particle is not only sliding, rather it is rotating also. ये क्या कर रहा है? Rotate भी कर रहा है और धीरे धीरे नीचे आता जा रहा है. So what will happen? At some particular R, it will just make a circle. So what is direction of centrifugal force? Suppose this is your radius of circle. Let's say this is distance d, and we can write d in form of r. So what is direction of centrifugal force? In this direction? Yes. And what is this value? m omega square d. यही होता है ना? Yes या no? Respond नहीं करोगे तो नहीं समझ में आएगा.
Yes, sir. Yes,
Yes,
sir.
m omega
Yes, sir.
square d in this direction. Now take the component of this into r direction. क्या होगा जरा बताओ? This angle is alpha. This is 90. So this angle is what? 90 minus alpha. So what will be component of this along this direction? क्या होगा बताइए?
M omega square alpha sin alpha.
Yes. So that value is m omega square d cos 90 minus alpha. है ना? So this value is basically m omega square d cos 90 minus alpha is equal to what? Sin alpha. Now, can you please tell me if d as a function of r? What is the relationship between d and r? बताओ. What is the relationship between d and r? d by r is equal to what? Sin alpha? नहीं?
Sin alpha.
है ना?
Yes, sir.
You can see something like this is r, this is d, this is alpha. So d by r is equal to sin alpha. So I can write d is equal to what? R sin alpha. ठीक है? So you can just write d is equal to r sin alpha. So we can put it here. So that value can be written as m omega square d is equal to r sin alpha into sin alpha is sin square alpha. By the way, what is omega? What is omega here?
Angular velocity.
एंगुलर वेलोसिटी. बट यहां पर क्या होगा? वेरिएबल में क्या होगा? आर थीटा फाई के टर्म में बताना है. व्हाट इज ओमेगा?
Phi dot.
Phi dot. Very good. So omega is phi dot. So this is m phi dot square r sin square alpha. So you can see this is exactly same thing. Are you getting my point? Exactly
Yes, sir. Both are-
same thing.
both are
Both are same thing. So what is this term? ये term बताओ क्या है फिर? इसको कोई explain करो. So this is component of weight in a r direction. What is this particular thing? ये क्या है? What is this particular thing? ये क्या है? This is component of centrifugal force along r direction. Positive r direction. और ये किस direction में है? Negative r direction में. Now you can see this is a constant term. M is constant, G is constant, alpha is constant. So this is constant. Now if r will increase, then phi dot will be decrease. When r will decrease, then phi dot will be increase. So when this particle will go upward, ये particle कब ऊपर जाएगा? This particle will go upward when mr sin square alpha phi dot square is greater than mg cos alpha, then this particle will move upward. Otherwise, when mr sin square alpha phi dot square is less than mg cos alpha, then particle will go downward. ये particle क्या होगा? Downward. Now, is that any some particular circumstances that it will neither go upward and not go downward? ऐसा होगा क्या? हो सकता है ना? At some particular circumstances, it will neither go upward nor go downward. It will just move in a circle. Yes? ये पूरा का पूरा circle में move करना रहेगा. So at some particular r is equal to r naught, you can have r dot is equal to 0, r double dot is equal to 0 because it is neither move up nor move go downward. So this value is r naught. So we can put it here and we can get what will be condition of circular orbit? So I am just removing this part.
Sir, at that point, both these forces should be equal.
Equal, exactly. This force is trying to take it upward. This force is trying to take it downward. And there
Yes,
may
sir.
be condition that these two things will be same. So you have the condition M R is equal to R naught. You have sine square alpha pi dot square must be equal to mg cos alpha. And that particular point pi dot can be identified as some omega naught. So we can write m r naught sine square alpha omega naught square is equal to mg cos alpha. So you can get value of omega naught. This m and m will be cancelled. And what is this particular omega naught? G upon r naught, and here cos alpha upon sine square alpha root under. होगा ये? You can write it थोड़ा सा better ढंग से लिख दूं. Actually space की बहुत ज्यादा जरूरत होती है ना? So this value is omega naught is equal to G, and what is this value? Cot alpha by R naught sine alpha. And what is R naught sine alpha? What is R naught sine alpha?
Sir, D radius.
D, the radius of circle, है ना? So you can write R naught sine
Yes, sir.
alpha. You can just go for radius of circle. ये TIFR के एग्जाम में आया था, है ना? So you can just easily find the omega naught in term of radius of circle. So आपको एग्जाम में देखना होगा कि ये रेडियस के टर्म में दे रहा है और it is given in this R. If this is given in radius term, then you can just write R naught sine alpha is equal to radius of a circle. Okay. So just try to do this problem again with yourself. Then you can easily go for next level. ठीक है? So next problem में चले?
Yes,
Yes?
sir.
Okay. Let's go for some simpler problem. है ना? Let's go for simple pendulum. और कल हम लोग डिफरेंट टाइप्स के पेंडुलम के बारे में बात करेंगे. ठीक है? मूविंग पेंडुलम, स्प्रिंग पेंडुलम, डबल पेंडुलम. ओके? चलो. So this is my simple pendulum, the simplest one. Most important problem for your exam. So this is your X and this is your Y. So simple pendulum is constrained to move in a vertical circle. So this is in vertical circle G. Okay. And vertical circle, that means it is moving in XY plane. It has mass M. This is length L. So the motion is confined into plane or something else. Plane, line or space. कहाँ motion confined है? Plane में. So if it is moving in a plane, so I can take it origin, and this value is equal to X and Y. Yes. And Z is equal to 0. Don't worry. And another equation of constraint is what? X square plus Y square is equal to what? L square. This distance is always fixed. Okay. So can I write Lagrangian of a system is half M x dot square plus y dot square minus mgy लिख सकते हैं? Because I have taken this as a 0, so this will add the negative potential. So I have putting this thing at minus mgy. Yes, it will depend on what is your reference frame. So we have just taken this as a reference frame and we are just measuring from there. Okay. Now, is that this Lagrangian is correct one?
No, sir.
No. Why not?
Sir, here DOF is 1 and we are using
Very
2
good.
generalized coefficient.
Very good. So DOF is equal to 3 into 1 minus 2, that is 1. So but we are using how many generalized coordinate? We are using 2 generalized coordinate. So this Lagrangian is not correct. Now, just tell me after watching the equation of constraint, which coordinate system is the best one? Just watching from the equation of constraint, which coordinate system is the best one? What is this equation? क्या equation है ये? किस चीज का equation है?
Equation of circle.
Equation of circle. Very good. Where is the origin or
Zero,
center? 0, 0. And what is radius?
L.
L. Now, so for the circular symmetry, what are the variables? R and theta?
R and theta.
Yes. So R is equal to what? L I can put. So I have to go for in which coordinate system for this thing? I have to go for what? Circular polar coordinate system. So R is equal to L. It's okay. Now, from where we have to measure theta? From horizontal axis or vertical axis? My question is that you can say this is theta or this is theta. Which must be theta? कौन सा theta होगा? Vertical. Why? Why vertical? Why not horizontal?
Motion.
Very deep-rooted answer. बताओ. Why vertical? Why not horizontal?
We will consider z-axis.
No, Z is this angle, this direction. So there is not any Z. Y is this one. X is this one.
Motion ही नहीं होगा x direction में तो फिर simple pendulum.
क्यों? X direction में motion ये तो XY plane में ही motion हो रहा है. XY plane का मतलब motion X में भी हो रहा है, Y में भी हो रहा है. Yes. My question is that you can take theta from here also. You can take theta from here also. The answer is correct. We will take theta from here also. So I will take this angle as my theta angle. But the question is that why you are taking this angle as theta, not this angle as theta? Due to this G. G किस direction में? In a vertical direction. So you just want to know how this is your direction of G. So how this particular mass is moving in the field. You just want to know. So why it is much better that you have to take angle theta with a vertical. In another way, what you can say that you are measuring angle theta with G. आप G के साथ एंगल को चेक कर रहे हो. So in a simple pendulum, we are taking angle theta with your vertical axis. So now, what will be X? R sin theta or cos theta? बताओ.
R sin theta, sir.
Very good. That value is what? R sin theta. What is Y? R cos theta. Now we can transform it. That value is half m r dot square r square theta dot square minus plus mg r cos theta. Now, what is equation of constraint we have to use? We have to use R is equal to L. This is your R. Okay. R is equal to L. So what is R dot? R dot is equal to 0. So you have L is equal to half m, and now L square theta dot square plus mg L cos theta. This is your Lagrangian. Is that any cyclic coordinate? Is that any cyclic coordinate?
No, sir.
No. In this problem, you don't have any cyclic coordinate. So just you have to go for equation of motion, that is d upon dt del L upon del theta dot minus del L upon del theta must be equal to 0. And this value is ml square theta double dot plus mgl cos theta must be equal to 0. Sorry, mgl sin theta. mgl sin theta is equal to 0. Okay. Now for the small oscillation, what you can do? You can just put sin theta is equal to what? Theta. For a small oscillation, you can put sin theta is approximately theta. So you can have theta double dot plus g upon L theta is equal to 0. So what is omega? Omega is equal to root under g upon L. Okay. पढ़ा होगा सब डिफरेंशियल इक्वेशन में ऐसा इक्वेशन है ना? Okay. So I will stop this class at this particular point. Tomorrow we will do different type of pendulums. ठीक है? So moving pendulum, rotating pendulum, and all kind of spring pendulum. ये सारा हम लोग करेंगे. Okay? So just tell me, are you people getting something or not? क्योंकि मुझे समझ में नहीं आ रहा है. Let me ask you everyone. So
Yes, sir. This is fine.
Kishore is okay. Anubha, are you okay? भागना नहीं, मैं फिर फोन करके पूछूंगा. ठीक है?
Yes, sir. Yes, sir.
अरुणा?
Yes, sir.
ओके. रूपाली, इसी बहाने अटेंडेंस तो हो जाएगा.
यस सर, आप हमें थोड़ा सा गाइड कर दीजिए कि जैसे जब क्लास खत्म हो जाता है तो उसके बाद जब हम खुद से रिवाइज करने, सेल्फ स्टडी करने बैठते हैं तो नोट्स के अलावा कुछ और रेफर करें.
देखो, सबसे पहले तो नोट्स पर कमांड करो. ठीक है?
ओके सर.
पहले नोट्स जब हो जाए और वो जब चैप्टर खत्म हो जाए तो आप प्रीवियस ईयर क्वेश्चंस पर कमांड करो. ठीक है?
ओके सर.
गुड. चलो अरुणा, आर यू कंफर्टेबल? भागना मत जिसे मैं बात नहीं कर पा रहा. हाँ?
Yes, sir.
पक्का?
जी sir.
ओके. एंड अश्वती?
Yes, sir.
पक्का? यू आर जस्ट
Yes, sir.
ओके. तो टेस्ट ले लूं अभी एक छोटा सा.
I didn't get you, sir.
Then I can take one test right
Yes,
now.
sir.
Okay, then good. Kishore, I think you are okay.
Yes, sir.
Mithra, are you okay? Mithra SW, who is there?
Sir.
Okay.
Yes, sir. Okay, sir.
So are you comfortable in the class?
Yes, sir. Yes, sir.
Okay. Neha,
Yes, sir.
good. Is that any problem?
No, sir.
Good. Sri Lakshmi,
Yes, sir.
Renu, how are you?
I'm fine, thank you.
ठीक हो? कैसा लग रहा है? And
Sir, अच्छा लग रहा
ठीक है, कहीं कोई प्रॉब्लम तो नहीं हो रही है? यू कैन जस्ट, कुछ प्रॉब्लम हो रही तो बात कर सकती हो, है ना?
है. No, sir.
ओके, ठीक है. रूपाली, सोनू,
Yes, sir.
इट्स ओके.
हाँ जी, sir.
Okay. And we have Srimaya.
No, sir. Free Ramya.
Sri Ramya. Okay. Sri Ramya. Okay, good. So are you comfortable?
Yes, sir.
Okay. So please try to do homework at least. If you are comfortable then.
Yes, sir.
Okay. Chalo फिर. Good night. Thank you.
Good night, sir.
Good night, sir.
Yes, sir.
Thank you.